Alright, looking at what they've given me, I am trying to prove a couple lines parallel. So let's look at which ones we're trying to prove parallel. I have line AB maybe, highlight that one. Line CD, I'll highlight that one. Showing, maybe showing a couple angles that are going to be the same, which would make the lines parallel. I'm looking at my picture and I'm seeing 3 and 2 here. If I draw in AC as the transversal, that would form 2 and 3. You know what type of angles those are? Those are alternate interior angles. So if I can show that 2 and 3 are congruent, that means the lines are congruent. So in the end, I'm going to say, well, if angle 2 is congruent to angle 3, then AB is parallel to CD. So that's long term. I'm going to try to get this right before the end and AB parallel to CD right at the end, because if I can show alternate interior angles congruent, then they're parallel lines. And looking at how I'm going to get there, I'm looking at what I have. Angle 1 is congruent to angle 2. Angle 1 is also congruent to angle 3. It seems that, well, if 2 and 3 equal to 1, they must be equal to each other. Which, to show that connection, I'm going to use the replacement rule. And to use the replacement rule, I need to have the measures equal. So I'm just going to take a moment and change these to have the measures equal. Change that by the definition of congruent angles. And what congruent means that all the measures of something are the same. So for an angle, all the measures, there's only one measure, you can just name those measures equal. The measure of angle 1 equals measure of angle 2. Definition of congruent angles. And then I'm going to try to replace. If you're not sure which one to replace, just pick one. I'll just pick the first one. If it doesn't work out, we might have to switch it. Yeah, I think it will. So can I replace angle 1 with anything? Actually, I can. That's also equal to measure of angle 3. Can't really replace anything from measure of angle 2. That's replacement rule. And then looking at the theorem I'm going to use over here, I'll circle that over here. If alternate interior angles are congruent, well, I have alternate interior angles 3 and 2 equal, but I don't have them congruent. And I know this, what I said over here at the beginning that I checked off first, 2 congruent to 3. Well, 3 congruent to 3, that's just as fine. As long as I have those two angles that are alternate interior congruent, that's enough. So I'm going to change this to congruent. Angle 3 is congruent to angle 2. Again, the same reason, you have that one measure equal, that's all you need for an angle to have all the parts congruent, or equal, to be able to say that they're congruent. Definition of congruency with angles. Again, if we show that alternate interior angles are congruent, then they're parallel lines. It's enough to conclude AB parallel to CD.